Well, on that note, you can read his bio in your brochures, but I would like to welcome our keynote speaker, Duncan Stewart, who is about to give us a presentation you will never forget. Duncan, please.
Hi, robot. So thanks, everybody, for being here. Thanks to Edison Tesla for the interruption and to Dr. Jones for the more official introduction. So this is based on our 2018 TMT predictions. TMT stands for Technology, Media, Telecommunications. This is a report Deloitte produces every year, and what I've done and did at a previous event was I customized this for this sort of audience. So one of the things is we've got lots of time for questions at the end, so do hold your questions till the end. We will have a chance there. Now, Deloitte's been doing these predictions since 2001, and since I have only seen, I think, one or two of you before in a presentation, I always like beginning by doing a little bit of a report card. So here's what we made as predictions in 2017. As you can see, there's a nice list, by and large pretty accurate. One of the things we missed on was DDoS, distributed denial of service. We were discussing the role of cybersecurity over lunch. DDoS attacks, there were a lot of them last year, but smaller than most people thought. In fact, the culprits behind the largest DDoS attacks, the terabit scale attacks, largely enabled by the Mirai botnet, luckily were arrested by the, I don't know if you know this, the Anchorage, yes, Anchorage, Alaska, FBI, and they arrested and have already convicted the culprits. And they are a sad bunch of 21-year-olds. I'm not kidding. It started off as a way of ransoming Minecraft characters. The world's largest botnet did actually come out of Minecraft. So little light on that one. How do we score these predictions? Well, there's sort of a nice example right here. We made a prediction last year. My friend Jessica, who invited me to this event, will know this. We talked about tablets. When tablets came out in 2010, a lot of people thought they were the magic device that was going to conquer the world, and we were all going to be using tablets. Since then, our phones have gotten bigger, and computers have gotten smaller, thinner, and lighter, and the tablet's getting squeezed out. Tablet sales fall every year. How good was our prediction? We said there would be 165 million tablets sold last year. Actual number? 164.8. We'll be closer next year, so that was pretty good. That was pretty good. When we look at all of our predictions, I'm co-author. Our prediction level last year was 90% accurate. I've never done that well in any school course, so I put this slide up everywhere I possibly can. I want to talk a little bit, beginning about the next big thing. Before I get into the actual 2018 predictions, I want to sort of do a little bit of an overview of the device landscape and new technologies looking out the next 5, 10, even longer. Let's start off with that next big thing idea. This is sort of a, I don't want to use the word greatest hits, but these are the sorts of things that if you watch the news coming out of CES every year, you've seen these. Remember e-readers? We were all gonna get e-readers. Sales of e-readers are falling about 25-50% year over year. Sales of e-books are declining 10-15%. 3D TVs, 2012 was the year of 3D TVs. We were all going to go out and buy 3D TVs. They, in October of 2017, the last remaining company that makes 3D TVs stopped making them. You can't even buy them anymore. Fitness bands are superb, right? You know, you get one and for Christmas, and you wear it and you count your 12,000 steps, and then you put it in a drawer and never look at it again. As I call them, fitness bands are the high-tech equivalent of the January gym membership. Last year, the world's largest manufacturer of fitness bands laid off half their staff. The second largest manufacturer went bankrupt. That kind of puts that in context. We got our friends, the smart kettle there. That's always a good one. Have you seen the smart kettles? Have you seen? This is quite cool. So you go out and you buy a kettle that's only $200 or $300 more than a normal kettle. You configure it to your local Wi-Fi network, install the app on your phone, you fill it with water, stand in front of it, hit a button on your phone, and this part's amazing. The kettle goes on. Weirdly, sales have been slightly lower than people expected. Drones, not enterprise drones. I want to talk about them in a second, but sales of consumer drones are disastrously low. World's largest manufacturer laid off a quarter of their employees 2 weeks ago. I want to tell a little story just because, electric utilities, stuff like that. So I'm a runner. Any other runners in the room? Yeah. So I'm a runner in Toronto. Has anybody here ever been to Toronto? It's a nice city. And a lot of people don't know this, but the single greatest virtue of Toronto is its ravine network. We have these ravines cut by the rivers, and down along the ravine valley bottoms, you can go for runs for hours and hours, and I see deer and all kinds of stuff. It's really great. Anyway, last year, true story, I wouldn't make a word of this up for you. I was out for a nice long run, couple hours, and I came down in the river valley, and aside from being a nice place to run, do you know what else you put in river valleys? Sewers. It's where you put the big trunks, right? So I'm running along, and I see 3 sanitation workers, the bright orange outfits, all rubber and stuff like that, and they got this weird thing. It's a carbon fiber cage with a drone inside. It was so cool, and it was really light. As a result of the propagation characteristics of the sewer acting like a waveguide, they could actually control it for up to 5 kilometers upstream. It had 2 cameras, a visual camera, but also an IR, and they were looking for a hot water leak using the thermal imager. It was brilliant. I just loved the idea. And so I asked them how they were doing and if it worked and all that kind of stuff, and it all seemed to go fine. But I have a little observation I want to make for the utility industry. I do this run all the time. I run, almost every day I can, and I've seen lots and lots of other sanitation workers in my life. So these 3 with their little drone and the cage, I have never in my life ever met warmer, drier, cleaner, happier sanitation workers than those 3. Stick the drone into the sewer, let it go do its job. Anyway, it's a nice example. Now, when we start talking about machine learning, which I will do later, I may actually mention drones again. Let me keep going, though. Once again, consumer drones not happening. 3D printers, huge in the enterprise. Huge in the enterprise. I can make stuff out of plastic, glass, ceramic, metal, customized products, usually short run, low weight, small volume, but nonetheless, it's transformative, a revolutionary technology. But the factory in every home? It turns out that devices that cost $1,000 take literally hundreds of hours of practice that at the end of the day make small pieces of plastic garbage are not a significant consumer product. Literally around the world, there are no remaining manufacturers of consumer 3D printers. Enterprise transformation, yes. Consumer, not so much. The final one I want to talk about is VR, virtual reality. We have the numbers coming in. There are certainly gamers out there who are buying VR headsets. However, the consumer market for this is literally 99% smaller than was predicted even a couple of years ago. Why? Well, it turns out that whether it's Google Glass or 3D TV sets or the Oculus Rift and HTC Vive, consumers do not like tying computers to their heads. Okay? This is not a radical thing for me to say. We've got 20 years of experimenting with this. This is not a thing that human beings like doing. In the enterprise, totally different. I gave a speech to the Society of Obstetricians and Gynecologists of Canada last year up in Ottawa, and we had 1,000 people in the room, thrilled and excited about the ability of using VR headsets in the medical technology world, looking at image. It's astonishing. Equally in your industry, utilities, we see a lot of potential for enterprise use, but not consumer. Now, all of this I'm putting together as a giant kind of reminder. This is just a short list of things that were supposed to be next big things. These weren't even next little things. Now, this one's a little hard. Luckily, you got screens on the side, so I hope you can see that. This is the Gartner Hype Cycle. Gartner puts this out every year. This is from July of 2017. Gartner says that all new technologies begin with an innovation trigger. You go up to a peak of inflated expectations, and then you plunge down to the trough of disillusionment. I love that phrase, trough of disillusionment. I want to open a restaurant called Trough of Disillusionment and see how it does. En français, le creux de désenchantement. Oh, sounds almost better in French. Then you come up the slope of enlightenment, the plateau of productivity. Okay? Now, that's a little hard to see, but the color scale here, I think, shows it. You've got these little color circles for less than 2 years, and then 2 to 5, 5 to 10, more than 10. And according to Gartner, the number of new and disruptive and wildly exciting technology showing up in the next 2 years is 0. None. Rien. Now, that does not mean that innovation has stopped. The technology world of 2023 and 2028 is going to be compelling and astonishing and exponential and all of those wonderful, innovative disruption buzzwords. That is all happening. But the technology world of 2020 and 2018 look almost exactly alike. We are going through a period of relatively slower change in new technologies. And that is not speculation. I can prove this to you. This chart is from my friends at the CTA. That's the Consumer Technology Association. They are the hosts of CES down in Las Vegas, and they put up this slide every year. According to CTA, global sales of consumer technology hardware reached $1045 billion. That's over $1 trillion in 2013, and they've gone down every single year since then. And I've run the numbers for 18 and 19, and they're looking like they go down again. Not a lot. Not a lot. Don't freak out. No need. This is like 1%, 2% a year. It's not a 30 or 40% decline. Now, in all honesty, and you know, looking at EEI, big kind of global perspective here, down 1 to 2%. That's not so bad. That's in nominal dollars. If I adjust for inflation and then I make it per capita, it looks a little worse, right? So it's going down. So that's the first point I want to make. First point, hardware growth not happening. Second point, if consumers spend less money on hardware, and they are, that means they can spend more money on software and services and electricity. No. And content. The way of thinking about this is around the world, people are keeping their old iPads longer but watching more Netflix and paying more money to their ISP for the data. What I just said is true in Africa, it is true in Asia, it is in LATAM, I can do this in Mideast, I can run Europe and North America. This is a global trend. There is a secular shift out of hardware towards software, services, and content. Now that's the first point I want to make. The second one I want to make is, of that $929 billion in 2017 just finished, what's the single biggest consumer hardware device in the world? Come on, you folks all know. I know you know. Smartphones, number 1. Number 2, computers, right? Number 3, this gets tricky. Number 3, anybody know? TV sets. TV sets, $110 billion a year industry. Okay, that was easy. Now comes the tricky bit. If I added all of the smartphones together and all of the computers together and all of the TV sets together, that makes a number. What percent of the $929 billion do those 3, and only those 3 devices add up to? Give me a guess. 90, little high. 80, much closer. Good job. 81%. When I talk to companies around the world, whether they be in media or technology, in public sector, private sector, big or small, over and over I get the question, hey Duncan, how much of my time should I spend on focusing on smart watches or whatever else? And my answer is always the same. Focus on smartphones, focus on computers, focus on TVs. Everything else is basically rounding error. You've never thought about that before, and I know you haven't, but that's a way of looking at it. Okay? Now, let's get started on the 2018 predictions. We're going to begin I'll always try tying this back together so that the Edison crowd here will appreciate it, but I'm going to start just by talking about, we got a color glitch on that one. That's a little off there. Anyway, We predict that there will be over 1 billion people creating augmented reality content in 2018. A billion of us make it, and it is such high-end, rocket science, sophisticated, amazing. It's not, okay, no, I lied. I just made that up. It's dog faces. It's mainly dog faces. And Easter's coming, so rabbit faces will be big too. I'm just saying. Not a big Easter crowd. I thought that would work better. I don't know. Anti-Easter group. I don't know. Okay, so everybody here get real down on augmented reality because it's about dog face. No, please remember in 1978, the first device that most North American homes ever owned in their lives that had a computer chip in it played digital ping pong. Many new technologies begin with the trivial and the gaming, and that is the thin edge of the wedge as to how they then become more transformative. So Duncan, can you talk about a more serious application of this? Yep, this is a nice one. This is an augmented reality app issued in late 2017. Nicely done, good lighting, nice shadows, good ability to sort of nail the floor and not have it float in mid-space. This is from an unnamed global furniture manufacturer that happens to sell a lot of meatballs with lingonberry sauce. IKEA. He's talking about IKEA. Anyway, this is the IKEA AR app for buying furniture, which is great. It's huge. It's amazing. It's awesome. It's absolutely going to transform the way. This is the 2013 IKEA augmented reality app that nobody in the world ever used. We've had the ability to do this for years. People don't do it. The reason we go to IKEA is we like walking through the store like a rat through a maze. We eat the meatballs, and we stick our children in the room with the little balls, right? That's the value proposition of IKEA, and that's why we go. Okay. I hear you challenging me here. Duncan, you're being a bit of a downer. Can we have a more optimistic one? Can you not come up with a single use case for augmented reality that is actually going to be used? I've got one. Does anybody here have a dog? Good. Does anybody here have a big dog? What kind of dog? Oh, yeah, how much does that weigh? 80 pounds? That's not even a dog. I have a Bernese mountain dog who weighs 127 pounds. His name is Hank. He is Hank. He is the best dog. He is the most perfect dog in history. Would everybody like to see a picture of Hank? You have to say yes. There we go. Now, it's a little hard to see. Can you make out the dog in this photo? Good. He's there. Yeah. Okay. For those of you with bad eyes, the giant furry thing is the dog. Now, what's a little harder to see, I don't know if you can see up here at the corner, there's actually a human being trapped under the dog. That's my wife, Barbara. And if everybody looks real close here at the corner, just up here, see this little triangle right there? That's where I sleep. This is all a true story. I wouldn't make any of this up for you. I said to Barbara, can we possibly get a bigger bed? But I live in an old house built in the 1890s, and it's got a kind of small staircase. So I wasn't sure that the new mattress would fit, so I used an augmented reality tape measure. I took a photo of the stairwell, and it showed that I had a solid couple inches clearance, and I now have a new mattress, and I am sleeping much better. Thank you for asking. Couple points. One, this is a genuine and non-trivial application. Point number two, and especially for my friends who are thinking about this as a tool for perhaps a utility worker. Does anybody else notice that the 48 on the AR tape measure is not in the same place as the 48? Well, because the thing is, when you're like cutting the whatever, 48 plus or minus 1 or 2 is, well, sometimes it matters, sometimes it doesn't. So I'm looking at this. Do I see AR in the utility industry? On phones, some of the time, sure, but also head-mounted devices. Google Glass is, in fact, finding a second life as an enterprise tool. Some of it is, for example, assembling wiring harnesses. GE is using this quite actively. When you're feeding 15, 20 different fiber optic cables with different color codes, having that displayed on an AR display, very useful. There's been a lot of talk about using it for line workers, folks going up the poles. There's some challenges there. Most of the AR goggles out there are, in fact, not weatherproof, so rain screen will not be a good thing. They are also not spark-proof, so sending somebody down into an enclosed environment where there might be an explosive gas would not be safe. One of the other challenges, if anybody here knows much about line workers, going up a pole and working with, multiple thousands of volts of live, you can't have an AR display dropping down a menu that blocks view of a critical thing. Finding the perfect utility application of this is something that will happen, but it's actually not a trivial process. So is AR coming fast to the electrical industry? Inside, yes. Get it out of the weather, that helps a lot. You've probably seen the Microsoft HoloLens demo of a utility worker using this. That's a nice example, but putting them up on poles, that could be a little longer, okay? So that's an example of the sort of thing I do. One of the ones I'm going to go through fairly quickly here. This is important because everybody's got a phone. Where did I put my phone? Can you pass me my phone, please? There we go. So I want to talk a little bit about the future of the smartphone because it matters so much. I hope everybody can see this, even at the back of the room. That's a nice picture of Barbara. Okay, maybe you can't see it that well. There's my phone. I'm currently about 5 meters away from my phone. If I put my new phone down and my old phone from last year beside it, I would be able to see the difference even from 20 feet away. My new phone is bigger. My new phone has a fingerprint sensor. My new phone has an OLED screen that's bright and crisp and clear. I could pick the two out from across a room. That's never going to happen again. Phones cannot get any bigger. They won't fit in our pockets. The screens we have now, the latest, greatest OLED screens, there's nothing on a lab bench anywhere that's clearer or sharper or brighter than that. Fingerprint sensors? Well, Samsung was actually kicking around the idea of coming out with a phone with 20 fingerprint sensors on it so you could use your feet too. That's a joke. I made that up. That's not true. I just was seeing if you were paying attention. My point is that the new phones at Mobile World Congress this year look exactly the same as each other and as last year, and it's going to be like that over and over again. All of the improvements that will occur in smartphones over the next half-decade will be under the hood. The innovation will still be there, but it'll be faster networks, machine learning chips, better sensors, better cameras. So there will be innovation, but it will be invisible to the average buyer. Now, everybody knows this if you've been doing technology for a while. The cool thing about technology is it gets cheaper every year. Yay, Moore's Law, right? That's fantastic news. It's not happening. The average selling price worldwide of smartphones in 2017 rose $22 from the year before. Deloitte is predicting it will rise a further $22 between now and 2023. And I'll tell you right now, we're wrong. It's probably going to be higher than that. Now, more expensive phones, more capable phones. Capable of what? And this is the one I really wanted to show to EEI. This is an analysis that Deloitte did for the European Union. We looked at every single job in the EU, which is, as you can see, hundreds of millions of jobs. Now, some of those jobs, when we looked at the tasks that could theoretically be done, please note the word theoretical. I am not saying that people are always doing all of these. Mainly, these are tasks that could be done on these devices. As you can see, using my little laser here, where's the laser? It's not that bright. Maybe I'm hitting the wrong button. Anyway, I'll point to it right here. Some jobs, you can't do much of your job on a mobile device. But there are other job categories where 75, 80, even 90% plus of the job tasks can be done on a Why will enterprises spend $1,000 on a worker's phone? Because they don't need to buy a laptop and a tablet and support them. The smartphone is an enterprise tool we all know about, but we use it for email and we use it for voice and just about nothing else. That is instantly about to start changing. Our mobile devices are going to become increasingly capable for some job tasks, and I would argue within the electrical utility industry, that's going to be actually a fairly big chunk of those tasks. I look at things like timesheet management and working with stock and third-party supplier management as things that transferring to phones, that would be a significant disruptor in our mobile workforces. All right, okay, everybody good? That was the easy stuff. Who here in the room is an electrical engineer? Brace yourselves, this is about to get fun. When we have conversations around machine learning, we have a tendency to obsess about the software. We have a tendency to talk about the data. Both of those are important. Do you know what we never talk about? We never talk about the hardware. Chips matter. Ready? Here we go. Beginning with this thought, whenever there is a revolution in the chips, when you change the chips, you change the machine learning. Now, everybody here knows what machine learning is, right? You don't explicitly program a computer, you expose it to data using machine learning algorithms and through a process of artificial neural networks and convolutional learning neural networks, we build a computer algorithm which can then do the inference portion. What is this useful? I'm gonna pause for a second here. Many of the problems in your industry, but in many industries, have been addressed by what have been called cognitive technologies for many years. Cognitive technologies used to, long ago, be called weak AI. We rebranded that about 5-6 years ago. Within that area of cognitive technologies, there used to be a whole bunch of hard problems. How do I get a computer to recognize human speech and translate it? Really hard, difficult thing to do. How do I translate it from one language to another? Tough, word by word, building up libraries, very difficult. How do I do speech synthesis? You would literally take phonemes and you would assemble them in the correct order and produce something that sounded not unlike my friend Edison Tesla. Okay? Image frame grabbers. Who here remembers frame grabbers? Am I the only one? Okay. Frame grabber was a kind of specific chip. What I would do is I would look at this table, and I would look at this here, and I would grab the edges of the glass. I would tilt back and forth, grabbing reflections. I would sketch out the outline, and I would see I would do edge detection. And putting that all together, I would say, it's a water glass. Actually, it worked very unreliably, and it was especially bad at transparent materials, but that's theoretically how we did it. Cognitive technologies in the year ballpark 2005, 2010, were silos. Each one of those was a separate field of artificial intelligence that worked not terribly well. Machine learning has conquered all. None of these are individual silos anymore. Every single one of these problems that people thought required distinct technological solutions have now been solved by this Lord of the Rings style, one ring to bring them all and in the darkness bind them. Sorry, bit of a Tolkien fan. I won't do that anymore, I promise. The idea being that machine learning was this thing that is now underlying every single form of weak AI in the world today. May I give you one example of that, Lawrence? Give me a little room on this one. Speech synthesis, I talked about that briefly. Go to the Google website, look up WaveNet. What they've done, so traditionally speech synthesis was done through phonemes. Google WaveNet has a demo. Here's an example. Picture this on a page in front of you. He deserted me in the desert. Whoa. Can you picture a computer reading that properly? Man, that's hard. So what Google's done is they said, instead of using traditional technology, let's do speech synthesis using machine learning. You can go on the website, and there's a bunch of audio clips of the Google WaveNet speech synthesis engine, and then there's the human professional recording artist reading the same sentence, and you have to try telling which one's the computer and which one's the human, and I'm telling you now you can't. Because they did a large statistically significant study, and there is no difference. Oh, and by the way, this was a 14-year research 11 months. 11 months ago, Google said, hey, I wonder if machine learning would work on speech synthesis. And they've now got it to equivalent to human. Human beings cannot tell the difference. That's an example, okay? Everybody with me still so far? Because it now gets technical. That was the fun bit. Now it gets technical. The first ever paper on artificial neural networks was, in fact, written in 1943. It's the seminal document out there. It's actually really clever, works very well. The only problem is there was no hardware at the time where you could do it. The CPU architecture of 1943 and 53 and 63, 73, 83, 93, and 2003 cannot run artificial neural networks and machine learning at the level required. The architecture is wrong. It's a highly serial architecture, and you need a more parallel processor to run this. Enter 2009, somebody got the idea to do machine learning not on a CPU, not a central processor like you find in your computer, but instead using a GPU, a graphics processing unit. This happens to be the one from a company called NVIDIA. These are multi-$1,000 chips that are extraordinarily good at high-end game rendering, and it turns out you can also stick them in a data center and do machine learning. GPUs were to CPUs 10 or 100 or 1,000 times superior. Okay? None of this is in dispute. This is all factual stuff. By the way, the world of machine learning in 2003 was a computer science dead end. If you studied machine learning, you were a joke in the field because it did not work. Machine learning did not work and had not worked for 60 years, even slightly. Neural networks in 2009 were transformed when they changed the chips. This is a 2017 chip. It is not a CPU. It is not a GPU. This is an ASIC, an application-specific integrated circuit. We have had ASICs for many, many years. The idea is instead of buying an off-the-shelf chip from an Intel or an off-the-shelf chip from an NVIDIA, you instead, if you are Google, spend $50 million in a couple of years building your own chip. It is not a chip that happens to be good at machine learning. Instead, it is a chip that is custom designed to do only one kind of learning. This is the TPU, the Tensor Processing Unit. It is a chip that Google has invented that does only TensorFlow machine learning, and it to the GPU is as the GPU was to the CPU, 10 or 100 or 1,000 times better. Okay? There are other kinds of chips. There are chips out there called FPGAs, field programmable gate arrays, are kinds of chips we've had for 20 plus years. They are unique in that they are dynamically reconfigurable so that for your machine learning inference algorithm, you can move between 1-bit precision and 15-bit precision in a millisecond. Is that a useful thing to do? Go ask Microsoft. They just bought 200,000 FPGAs to accelerate machine learning in their data centers. There are many, many other chips going on, all of which together are being used, expanding the market. They do not replace the GPU, but complement it. Now, that was all hardware. We're now going to do a little bit of software chit-chat. One of the things that machine learning requires is data scientists, and there's a shortage of data scientists out there. You can't get them. You can't keep them. Facebook keeps trying to hire them away, okay? So what do you do? One of the interesting things is that about 80% of the tasks that machine learning data scientists currently do can, should, will, are being automated. Does anybody here use Excel very much, Excel spreadsheets? Yeah. Does anybody else here dream in Excel? Is that just me? Okay, that's just me. Sorry, Paula. Remember when you import an Excel spreadsheet and you have to go through all the rows and columns looking for like blank cells? It's not a perfect example, but that's real similar to what data scientists do 80% of the time. It's that really kind of low-level data scrubbing. As that stuff is automated, 4 out of every 5 machine scientists will be fine. No. We will better use the ones we already have, which allows them to do more higher value-added productivity, 80% being automated. Data reduction, if you don't have enough data, you can't train your data set. There's a thing out there called synthetic data that allows you to take your existing real-world data, complement it with artificial data, and still be able to produce a usable machine learning inference pattern. Better chips, I mentioned already. Model interpretability. Got to spend a second on this one. Machine learning's great. Machine learning was, for example, behind that computer that beat the world Go champion, right? You saw this? That was really impressive. That was really hard. You don't really care if the computer came up with a better move, how it came up with it. That doesn't matter. That's not important, right? As long as it wins, that's all that matters. Anybody here ever remember in like grade 11 math, you took that test and you knew the answer was 42, and you wrote down 42, and you got 0 out of 10 because you did not show your work. That's what machine learning is. It is called black box decision making. It comes up with an answer, but you don't know why it comes up with an answer. That doesn't matter when you're playing Go. It does matter when you're denying an insurance claim, prescribing a chemotherapy, or approving a loan, or any other government public sector program. Does anybody know why this matters so much, by the way? It's kind of a sensitive topic. I'm cautious raising this, but it's so important. I got to point it out. Does anybody know? A lot of people think we've got a problem in society. We're biased against men or women or old or young or by race or by religion or whatever it is. We'll hand it over to machines. That'll get rid of the bias. Doesn't work that way. Machine learning does not eliminate bias. Machine learning does not record the bias of society. Machine learning amplifies the bias of society. So when we are denying loans to somebody or housing or welfare benefits or medical, there is a huge group of areas where we cannot use machine learning up until now. Because there's a new thing out there called model interpretability. It effectively shines a flashlight into the box of machine learning, partially illuminating it, effectively doubling the ability of machine learning to be used in multiple marketplaces where it otherwise couldn't. Last two, we're going to go to questions in about just a few minutes. But I want to finish off on machine learning because this is so important. And I'm spending a lot of time on it, but this is, I think, not just the most important prediction for this year, I think it's the most important prediction I've ever talked about. And I'm going to try drawing all the web together in about 3 minutes, so hang with me on that one. Before I do, does anybody have one of the new iPhones? 8, 10? 10. Inside that iPhone, there's a new chip. Daniel, do you know what it's called? It's called the Bionic chip. No, not the A10. No, not the processor. There's a special chip called the Bionic. It's actually half Lee Majors and half Lindsay Wagner. Okay, see, nobody else in the rest of the room got that. I just dated myself really badly. Never refer to 1970s TV show in public again. Got it. Okay. Nah, it's called the Bionic chip. Remember those ASICs I talked about? Application-specific integrated circuits? The Bionic is an ASIC that Apple built, designed, invented. Cost them $50 million. It's on every new iPhone. And it does onboard machine learning. You know what else it does? Absolutely nothing. That's it. Apple believes that putting a dedicated chip to do machine learning on that device is valuable enough that it will be a product differentiator. Now, so who are my engineer friends? Were you an engineer, sir? Electrical? Excellent. So you tell everybody if I get something wrong here. When we talked about the history of machine learning, I talked about those NVIDIA GPUs. They're real cool from a technology world. They're real hot from an actual energy. An NVIDIA graphics accelerator chip in a data center runs around 285 watts. Statement of literal fact. You touch it, you burn yourself badly. It's like touching a stove. Now, the Bionic chip, that doesn't use that much power. That might be 200 milliwatts. But I want to put this one up because this is interesting. This is an academic paper that was published in February of last year, and it talks about a programmable deep learning processor. For those of you who don't know, that little backwards U is micro. In a 2-year period, we've gone from machine learning processors that use 280 watts to one using 288 millionths of a watt in 2 years. Like that makes Moore's Law look like nothing. Like that's incredible. That's 6 orders of magnitude in 24 months, folks. Now, why am I telling you this as an electric utility? Hopefully you're kind of ahead of me on this. One of the biggest draws in the world today for electricity in data centers is machine learning. If the machine learning industry is able to dramatically decrease power consumption, you actually need to start thinking about that. Because it means they're going to use less electricity, doesn't it? Nope. It means they're going to do more machine learning. Always, right? Remember when you bought your first PC and they told you didn't need the 20 megabyte hard drive because nobody in the world would need that much memory? Memory and data expand so as to fill the room. If we make machine learning use less power, we're just going to end up doing more machine learning. point one. Point two, where could I put a 288 microwatt device? Come on, give me some ideas. There tends to be a lot of power in a substation. Thinking more about the smart city stuff we were talking about. Not so much the kiosks that you're working on, but think about it inside a roadway with no power. Literally, imagine a device powered by a piezoelectric. The energy of the car tires going over actually provide the power for the machine learning that detects the emergence of black ice in real time, signaling dangerous roadway to the cars all around. All of it passively done with literally microwatts of power. Or a little more science fiction inside the human body, right? That's a little further out. Let me put this all together for you. I am not talking about Google Alexa. Amazon Alexa or Google Home. I'm not talking about the little smart speakers. Those are fun. I love them. I'm talking about enterprise use. I'm talking about the biggest companies in the world, the biggest governments in the world, the biggest utilities in the world. The use of machine learning will double in 2018 compared to 2017 and will double again by 2020. There are very few things in this world that truly have exponential 100% growth. This is one of them, and it's already a $10 billion plus industry, and it's doubling every year. Where? Everywhere. IT department, customers, financial, marketing. Which parts of a company will use machine learning? All of them. Well, big companies or little? Both. Which industries? All of them. Public or private? Both. I cannot overstate this. Now, this is a fun slide for me to put up because I put this up around the world and nobody ever knows what I'm talking about, and if you don't, nobody gets dessert, okay? Are we all clear? This is the top of an 1888 building being completed in Washington, D.C. Nobody has ever gotten this right before. Please, somebody in the room, answer it correctly. What is this a picture of? Top of the Washington Monument. Thank you! Sorry, I've been doing this for 2 months and nobody's gotten it right. I'm kind of glorying in this moment. Does anybody know what the top of the Washington Monument is made out of? Bingo. It's aluminum. 1888, aluminum had only recently been isolated. And it was scarce. It was more expensive than gold. So they topped the Washington Monument with a piece of aluminum, and that's really kind of interesting. But what's much more interesting is that in 1888, nobody did anything else with aluminum. It was too scarce and expensive. 2 years later, a French scientist and an American scientist separately made two breakthroughs about the purification of bauxite and then changing that into elemental aluminum, and the price of aluminum dropped by 1,000 times. All true story. And aluminum went from something that you topped the Washington Monument with to something that is used in literally every form of manufacturing in the world today. And my point about this is that if I went, I'm turned around, I don't know which direction I go, that way I think. If I went to the Washington Monument and I climbed up the outside and tried stealing the little aluminum, which is admittedly a bad idea, I'm not about to do this, and I took that little piece of aluminum and I pounded it, and I pounded it and I pounded it, really super, super, super flat, I could still wrap lasagna in it today. My point is you didn't need to make the aluminum better in order for it to transform the world. All you needed to do was make it much, much cheaper. On its own, that is enough. Where do I want to go right now? Just think about drones. Think about drones flying along, surveying power lines, checking out trees, tree growth. Think about a drone moving at 20, 30, 40 miles an hour in high winds, watching trees move back and forth, and then using angular resolution to try to pick up a wire this thick and see, for example, if it's got a coating of ice in it. Can you even begin to grasp the machine learning opportunities for image detection, auto-stabilization, all that kind of stuff? That's just one. I just pulled that. I just pulled that out of my brain as a random example. And I can do that over and over. Predictive failure is going to be a huge thing. What is the mean time between failure of whatever inside a substation? I don't know. Throw some machine learning at it and watch as it breaks down in real time across a network, letting you know that this device, this whatever it is, isn't broken. I mean, yeah, everybody, I always know when something shorts out and is broken. That one's easy. Tell me before it does. All right, 2 seconds. I want to do one fun one. Can I do one fun one? Okay. Okay. Because, I mean, you said I got 45 minutes, but we started a little late. Okay, good. So, anyway, there's recorded. We've had recorded for a long time. That's all good. Is it my favorite record album? It's just not just video. Netflix did not invent watch what you want when you want. It's been around for a long time. But my favorite record is by an American artist released in 1977. It's called The River. I'm not sure if anybody knows of this guy. His name's Bruce Springsteen. Any Bruce fans in the room? No. The proper answer is Bruce. Has anybody here ever seen Bruce Springsteen live? Best live show in history. It's amazing. Man runs back and forth for 4 hours. He's incredible. So anyway, Bruce was doing the River Tour in Buffalo, New York, which is a reasonable drive from Toronto. So I had to spend a couple $100 getting the tickets. It was cool. I got them online. Didn't have to go through a scalper. Couple hotel room for the night. And of course, you got to buy the merch. So I got a T-shirt. Well, when I say I got a T-shirt, that's Hank the dog wearing my T-shirt. I love that shot. It's Hank. So anyway, Bruce is now doing a residency on Broadway. Do you know that? 72 shows, couple hours, Bruce and a guitar. They're going to make a movie out of it. But I'd love to see it live. Now, all the tickets sold out pretty fast. So I said to Barbara, let me check. Maybe we can get him through a scalper. Maybe for Christmas I can buy you a couple tickets to Bruce down on his Broadway residency. After all, how much could it cost? Yeah, that's U.S. dollars per ticket, by the way. So I told Barbara, honey, instead of going to Bruce, how about I buy you a nice house in the south of France instead? $4,553 per ticket. People are paying this. Why? Because they think it's worth it. The global live industry is $545 billion in direct revenues. Growing. Live is not dead. This has got nothing to do with Edison and utility. This is just the kind of media stuff that's also part of predictions. I got a whole bunch of other ones that I'm going to skip over. Real quick, super quick. This is just Canadian data as it happens, but I can do this for the US. I can do it for a lot of different countries. Just a couple quick points here. You know what the number one device for young people watching TV is? It's the TV set. Yes, they watch on smartphones, and yes, they watch on computers, but 59% of young people still say their favorite device for watching TV is the TV. Bigger screen, bigger sound. But the one I want to talk about is making online purchases, 61%. When I talk to young people, and I say, how do you buy your shoes? This is a true story. They say, well, sometimes in stores, sometimes online. And I say, when online, do you use your smartphone or your laptop? They say, laptop most of the time. And I go, why? You don't like the app? App is fine. Well, you don't like using your phone? I love my phone. You don't like making payments on your phone? I love making payments on my phone. So why do you buy shoes on your laptop instead of on your smartphone? And they look at me, like a bunch of people just did right now, like I'm an idiot. And they say, because it's got a bigger screen and the shoe looks bigger. My point is, when we talk about 18 to 24-year-olds being mobile only, it's not true. There is lots of stuff they do on their phones, don't get me wrong. More than half they do on their phones, don't get me wrong. But form factor matters. Big screen, big keyboard. How is this relevant? Well, there's going to be a lot of tasks in the world that we're able to drive to our smartphones. But it's not everything. Sometimes big screen, big keyboard matters. Last one. This is super quick, and then I'll throw it over to questions. This is quite important. I have data for the United States. Please send me a show of hands. Who here has the internet? I don't know if you've heard of it. The internet at home. Good. Okay. Great. Who gets it from a cable company? Who here has a cable ISP? Okay, me too. Who here gets it from a telco like Verizon or AT&T? Okay. Now, who here gets all of their at-home data, 100% of your data in your house, cellular only? You do not have a wire for your data. All of it is cellular. Hands, please. Don't be shy. All cellular? Not Wi-Fi, I mean cellular. Cellular is... Okay, there's one. Not a lot. 19% of Americans are mobile only. 1 in 5 people in the United States do not have wireline internet. They just aren't in the room right now. Who are those people? First guess. They tend to be poorer. Poorer Americans are much more likely to be cellular only. Who else? Younger Americans are much more likely. And last one, who else? Who's the third category? Sorry? Did you say something? Rural. Yeah, rural people. Yeah, I knew where you were going. Bingo. I don't have the U.S. slide. I'm sorry. This happens to be Canadian. We've got somebody from the Canadian Embassy. She can vouch that this is an accurate slide. This is from CRTC. It's the equivalent of the FCC up in Canada. And what we are looking at here, this is the Toronto Golden Horseshoe. This has the population of about 8.5 million people. And the point I want to make here is that the light blue is where a telco is, the light purple is where a cable company is, and the dark purple is where you got a choice of either or. Everybody got that? And white is where you cannot get wireline internet access. Because when we have this conversation in Canada and the United States, and in Africa, and in Brazil, and in Australia, when we have this conversation about urban and rural, we have a tendency to think, in Canada, the reason you can't get it is the polar bears keep knocking down the wires. So do you see this white dot right here? I have a friend who lives there. His name's Brian Piccioni. Brian Piccioni doesn't have wireline internet because he can't get it where he lives. Brian Piccioni lives a 42-minute drive from downtown Toronto. Rural Canada, and may I add, rural US and rural France and rural Turkey begin 30 to 40 minutes outside of our downtown cores. Why does this matter? Because if you're connected to the internet over only a cellular network, you are sipping through a straw and watching the meter. A lot of implications there in terms of internet access. We'll talk about 5G in the Q&A if we get to it. This is the last slide that I put up. I always put this up. Please do email me if you have an in-depth question you want to reach. Follow me on Twitter. I talk about this kind of stuff. LinkedIn, for sure. I post articles. Just posted one today on some real interesting stuff. Same with Facebook. Instagram, largely pictures of Hank, but, that's okay if you really like Bernie's Mountain Dogs. On that note, questions? Clap after the question. See how I do. Yes.